Okay, this is part 2, and I want just to recap a little bit from what we just did. In part 1, is we talked about the definition of the trig functions in terms of the coordinate plane, and so if we have some angle here, and this coordinate is x, y, and the hypotenuse is r, then we could drop an altitude, and create this right triangle. And by definition, we said that sine of an angle is equal to y over r, which makes sense because if you look at this triangle, the opposite side would be y, and the adjacent side would be x, and then r, we use r because it's the radius of the circle created going through that particular point. Excuse me. We've got cosine of theta is x over r, and tangent of theta is y over x. And so if we think about, and so looking at this, this triangle I have in this picture here, there's actually a relationship between these three variables, x squared plus y squared equals r squared. So it's the Pythagorean relationship, which means if I know two of the coordinates, I can find the third. And we'll talk about that a little bit later, probably in part 3. All right, so, so if we're talking about the unit circle, where r is 1, then we can, so if r here equals 1, then we can talk about how, so I'm going to put my little angle here, then we can say that sine of theta, which is y over r, would just be y, and cosine of theta, which is x over r, would just be x, and tangent, of course, would still be y over x. So in terms of the unit circle, then every point on that unit circle can be thought of as cosine of the angle formed, comma sine of the angle formed, which is a little bit of a hard concept to think about. And again, that's in the unit circle. All right, so let's evaluate the trig functions at some special angles. And this corresponds to, when you get to the worksheet, this corresponds to number 12. And it'll be number 12, which is in degrees, and number 15, which is, not 15, sorry, 16, which is in radians. Okay, so let's do, what if I asked you to find the sine of 120 degrees? Well, the first thing you're going to do is draw 120 degrees, and you think of a point on the terminal side there. And, well, what are the x and y coordinates of that point? Well, to figure that out, or possible x and y coordinates of that point, I should say, we can drop an altitude and draw a triangle. And and how can I get these points? Well, luckily 120, the difference between 180 and 120 is 60 degrees. So I'm actually creating this right triangle, and it's a special right triangle so that I can put some coordinates or some lengths to the sides. So opposite 60, so let's actually do opposite 30. If we think about the ratios of the sides, opposite 30 I can have as 1. You just have to be careful though, because we're in the second quadrant here. The x coordinate is going to be negative. So -1, opposite 60 is √3, and then opposite the hypotenuse will be 2. So now I go to my definition of what sine is. It's y over r. So in this particular case, the sine of 120 would be √3 over 2. Whereas if I were to do the cosine of 120 instead, which is x over r, it'd be -1/2. Okay, let's do another one. What about if I said to do tangent of -30? So let's do tangent of -30 degrees. So -30 will be in quadrant 4. And when you draw your triangle, and this will be 30 because we're doing -30, but I'm just going to write it as positive because we're going to be dealing with a 30, 60, 90. You're always going to draw your triangle or drop your altitude to the closest x-axis. to correctly reflect the x and y coordinates. So the x coordinate here, if it's going to be opposite 60, is +1, since quadrant 4 x is still positive. Not 1, sorry. Positive √3. Opposite 60 is √3. Opposite 30 is 1, but because we're in quadrant 4, it'll be -1, and then opposite the 90 will be 2. So tangent of -30. Tangent is y over x, so it'll be -1 over √3 or -√3 over 3. Oops. Okay, what about, let's see if I want to do, let's just do, what if we wanted to do tangent of 225? So if we were doing tangent of 225, that's going to be in quadrant 4. This is quadrant 3, not 4. And again, we drop the triangle, the altitude, to create the triangle with the closest x-axis. And the difference between 225 and 180 is 45. So I'm working with a 45, 45, 90. And opposite 45, each of the legs, we can say 1. And then the opposite 90 is √2 times that. But because I'm in quadrant 3, both x and y are negative. So both would be -1. So tangent of 225 is y over x, -1 over -1, which is just +1. The x and y's being negative, both negative, make actually the tangent positive. And you're going to do the same thing in, I think I said it was number 16, when we're talking about, when you talk about radians. So remember, in radians, pi over 3 is 60, pi over 6 is 30. These are the important ones to know. Pi over 4, in terms of the special angles, pi over 4 is 45. So when I think of, for example, doing, say I wanted to do tangent of 2 pi over 3, you could think, at this point, you probably will, 2 times 60, which is 120. But you're going to come to think that, well, it's in quadrant 2 because pi, which is 180, would be 3 pi over 3. So it's a pi over 3 less than that. So I'm dealing with this difference being pi over 3. Again, totally fine if you're thinking, okay, 2 pi over 3 is 120, so 60 is left over. So we're working in a 30, 60, 90 triangle. And so opposite the 30 is 1, but it's going to be -1 because I'm in quadrant 2. Opposite the 60, or pi over 3, is √3, and then 2. And tangent, remember, is y over x, so it would be √3 over -1 or -√3. So you're going to be doing some practice with evaluating the trig functions at special angles in both radians and in degrees. And again, the radians may take some time, and I totally get it if you're converting it to degrees. I wouldn't convert by multiplying by pi over 180. Instead, convert, if you're doing that, which again I totally expect at this point, is knowing that all of these are 60, 30, and 45, what multiple of that are you dealing with? Like, for example, 5 pi over 6 is 5 times 130 or 150. So thinking about it in terms of pi over 3, pi over 6, and pi over 4 will be helpful.